So the second quadrilateral we're going to talk about is a rhombus, which is a parallelogram with four congruent sides. We're going to go through the same process as we did with the parallelogram in terms of the construction and focus on some additional properties a rhombus will have. So to construct it, remember a rhombus has four congruent sides. So we have to make sure when we construct it that we get that to happen. So what we're going to do is construct a circle. Then within this circle, we're going to construct our first two segments or the adjacent sides of it. The reason of this, using a circle, is we know in a circle all radii are congruent. Okay, so that makes sure our first two sides are congruent. So now we can go ahead, we can hide the circle and this point here. Oh. So now we can go through and construct the rest of our parallelogram. Parallel to this line through this point, parallel to this line through this point. Then we're going to go ahead, mark this intersection. Then we want to hide these two extended lines so that we can go ahead and make a nice, clear rhombus. Now we already know when we measure all four sides, if all four sides are congruent, we know opposite sides are congruent. And so just to show you it's a rhombus, let's go ahead and measure those sides and move them into place. Okay, so here you can see that all four sides are congruent, which makes it a rhombus. Now we're going to go ahead and measure all of the angles. And because it's a parallelogram, we know right away that the opposite angles will be congruent only because a rhombus is a parallelogram, so it's already going to have those properties. But are there additional ones is what we need to figure out. Well, as you can see, right, the opposite angles still remain parallel or congruent, and adjacent angles are still supplementary. And that's about all we get from there. I'm going to move these angle measures outside so that we can go ahead and construct the diagonals. Now, right away, here, let's go ahead and check to see, are these diagonals congruent? Well, as you can see, one of the diagonals, the shorter one is 3.7, the larger one 7.6. So the diagonals are not congruent. So let's go ahead and undo those measures. And now we want to measure the angle at the center, right, of the rhombus. So we're going to create that point. We're going to go ahead and measure all these angles in the center. So if I measure this angle here, look what happens, right? This angle ends up being how many degrees? 90 degrees. Okay, and think about it. If this is 90 degrees, aren't all four of these angles going to be 90 degrees? So right away, if we go to our worksheet, we already know that the opposite sides will be congruent because all four of the sides are congruent. Were the opposite angles congruent? Yes. Were the adjacent angles congruent or supplementary? We said these are still supplementary. And the adjacent sides were congruent? Yes. And that's because all four sides were congruent. So we know the neighboring sides were congruent also. We constructed diagonals. Were they congruent? No. And when we plotted the point and measured those angles, right? Oh, we'll jump to number 7. When we plotted the point at the intersection and measured those angles, are the diagonals perpendicular to each other? Yes, because they are all 90 degrees. Now, right away, do the diagonals bisect each other? Well, if it happened in a parallelogram, it's going to happen in a rhombus, so yes. And to show you real quick, right, if I go ahead and measure this segment and this segment, you'll see those are congruent, and these are congruent, and these are congruent. So right away that tells us the diagonals bisect each other. Okay, now next, do the diagonals bisect opposite angles, right? So when I look here, and I'm just going to hide all these measurements, what we're going to measure is we're going to measure these two angles. So we're going to measure this angle here, and then we're going to measure this angle here. And if I move the measures so it's easier to see them, that's 26.1 degrees, that's 26.1 degrees. And if you look, I can go around and measure all of these angles. And if you think about it mathematically, right, how does this work? Well, right away you know all of four of these angles are going to be congruent, because if the opposite angles are congruent and this diagonal bisects them into two congruent angles, I know all four of these will be congruent. Same with this side. If the opposite angles are congruent and the diagonal cuts or bisects the opposite angles, I know all four of those will be congruent also. So right away, can we say the diagonals bisect the opposite angles? And the answer to that is yes. So the next two theorems that we're going to have with a rhombus is, one, the diagonals are perpendicular, meaning they create 90-degree angles at the center. Okay, and then we could also say the diagonals bisect opposite angles. All right, so when we look at it, you also have to include, right? So a rhombus has these two properties in addition to all of the properties of a parallelogram. You have to keep that in mind. So if we look here, right away, easiest way to find the value of the variables in this rhombus, well, if you look at it, all three sides, or all four sides, are going to be 15 units long. So you can set opposite sides equal to each other, but it's much easier to see, well, 5x has equal 15, so x is 3. Then what does 3y have to equal? 15. So what is the value of y? 5, sorry. Okay, so don't make that problem harder than it needs to be. If it tells you it's a rhombus, all four sides are congruent. Now, in a rhombus, if angle n is 120, right away I know four sides are congruent. And if you think about it logically, what type of triangle is that going to be? And the best answer for it is isosceles. So if we know that's an isosceles triangle, we know these angles are congruent. So if we do 180 minus 120, we get 60. And if we divide that by 2, that tells us each of these angles are 30 degrees. And if the diagonal bisects opposite angles, right, we know this has to be 30 and that has to be 30. And if I wanted to, what would the measure of angle Q be? 120. Okay, so think about it using like the fact that these are isosceles triangles. In example 3, right away, what's the easiest angle measure to find here? And that is angle 2, because you know right away these diagonals are perpendicular to each other. So right away, you know angle 2 has to be 90 degrees. To find the other angles, angle 1, you should know that all four of these angles will be congruent. So 1 will be 78 degrees. Angle 4 will be 78 degrees. Okay, so all of these angles will be 78 degrees. You could also tell that if we use the idea of parallel lines and alternate interior angles, angle 4 and 78 end up being alternate interior angles. So now to find angle 3, well, just use this triangle here. If I use this triangle, right away you should see all three angles will add up to 180. So 180 minus 90 minus 78 is going to give you 12 degrees. All right, so on to the next one. ACDE is a rhombus, okay? Now they're telling you AB is 2x plus 12, and they're telling you BD is 3x plus 8, then CB is 3y plus 5, and CE, right, is this whole segment is 34. Now, with this, how do we find x and y? Well, x is easy because right away, you know, these segments are congruent. So 3x plus 8 is equal to 2x plus 12. And right away, subtract 2x, I get x equals subtract 8, 4. But to find y, you have to kind of look at it a little differently. Remember, 34 is the length of CE. So if that whole segment is 34, what's the length of each of these pieces going to be? Well, take 34 divided by 2. This piece would be 17. This piece would be 17. So now to find y, 3y plus 5 equals 17. 3y equals 12. Y is equal to 4. Some people might also do 3y plus 5 plus 3y plus 5 equals 34. That is perfectly fine. Now to find the measure or the value of m, they tell you angle ABC is 8m plus 34. Well, right away, what is the measure of angle ABC? We know since the diagonals are perpendicular, that's 90 degrees. So 8m plus 34 equals 90. 8m equals 56. So m is equal to 7. Okay, go ahead, try the homework, and let me know if you have any questions.